Imagine a liquid, but with atoms that don't move. Sounds impossible, right? Well, scientists have just discovered a bizarre hybrid state of matter where part of a liquid behaves exactly like a solid, and it's rewriting what we thought we knew about how matter works. Researchers from the University of Nottingham and the University of Ulm in Germany have revealed something stunning. Inside certain liquids, not all atoms are sloshing around like a chaotic crowd. Some atoms stay perfectly still, frozen in place, and those atoms can trap entire liquids in a strange, supercooled limbo. For decades, we've neatly categorized matter into solids, liquids, and gases. Solids are structured, liquids are loose and mysterious, and gases are totally free. But liquids have always been the hardest to truly understand, especially the exact moment where a liquid transforms into a solid. That moment decides everything: crystal shapes, strength, functionality, from minerals and ice to metals and even biological materials. So the scientists wanted to see that transformation up close, atom by atom. To do that, Dr. Christopher Leist used a powerful tool, the low-voltage salve transmission electron microscope. This isn't a normal microscope. It can see individual atoms moving in real time. Leist and the team began by melting tiny metal nanoparticles, gold, platinum, and palladium, sitting on an ultra-thin sheet of graphene. Think of graphene like a microscopic stovetop. When the metals melted, the atoms should have been moving wildly, like boiling water. But that's not what happened. To their shock, they found atoms that did not move at all. Even at extremely high temperatures, these atoms stayed locked in place, bonded tightly to tiny imperfections in the graphene. These unmoving atoms acted like anchors inside the liquid metal. Then the researchers took things further. They used the electron beam to create more of these defects, more places where atoms could get stuck. And suddenly, they had unprecedented control over the number of frozen atoms in the liquid. And that's when things got weird. With just a few stationary atoms, the liquid still formed normal crystals. But with a lot of stationary atoms, especially when they formed a ring-like shape, the metal didn't solidify normally. It got trapped. The liquid became corralled, like an animal in a fenced pen, and stayed liquid far below the temperature where it should have solidified. For platinum, the team observed liquid metal at temperatures more than 1000 degrees Celsius below its normal freezing point. That is unheard of. Professor Andrei Klobistov explained it like this. If the stationary atoms form a ring around the liquid, it's stuck. It can't solidify. It becomes this strange hybrid state, liquid on the inside, solid anchors on the outside, a completely new form of matter. And when this trapped liquid finally does solidify, it doesn't become a normal crystal. It turns into an amorphous solid, a kind of unstable glass-like material. Only when the atomic corral breaks does the metal finally crystallize properly. This is the first time scientists have ever corralled atoms like this. They've done it with electrons, even photons, but never with actual atoms in a liquid. Why does this matter? Because this control over how materials melt and freeze could completely change how we design future technologies. It could lead to better catalysts, longer-lasting materials, and more efficient ways to use rare metals in clean energy, like batteries and hydrogen production. This discovery doesn't just deepen our understanding of matter. It opens the door to a new class of materials with properties we've never been able to access before. The study was published in ACS Nano, and scientists believe this is only the beginning.